Hey guys, welcome to Java Shorts. Today's topic, Bitwise Operators and how they work in Java. Here we go, Bitwise Operators. So there are 4 of these. We're going to look at the first 3 first, and the first of those 3 is Bitwise AND. Bitwise AND is this ampersand right here, and returns true if both arguments, both of these to the left and to the right of the ampersand, are true. Only then will it return true. The second one, Bitwise OR, this guy right here, if at least one of the arguments is true, either here or here, that's going to return true. And the last one, last but not least, and certainly the one with the coolest name, this caret here, XOR operator. If both arguments are different, it's going to return true. So for example, true and false, that will return true. So, quick example of them in action. Here is the AND operator, true and false. We said both of these need to be true for it to return true. Well, obviously these are not both true, so that's going to give us a false. True or false, only one of them needs to be true, and we've got it right there. So that's going to give us a true, and true XOR false said they need to be different. What's more different than true and false? So that one obviously is going to return true. Now what about these here? Is this even valid in Java? Now you look at this and you think, it looks like something, maybe this is valid in C, Java, maybe not so much. But if we were talking about the conditional operators, like the double ampersand, double OR, that would be correct. But this is actually valid in Java. So what are you thinking, true or false? We got 5 and 7. Seems what, maybe false. 5 or 7, oh, either one. Okay, that's probably true. 5x or 7, we said they needed to be different, so that should be true also. Well, that's not exactly what's going on here. So let's see. 5 and 7 is going to give us 5. 5 or 7 is going to give us a 7. Okay, so we're comparing integers. We're going to get an integer back. 5x or 7, is that going to give us a 5 or a 7? What do you think? So 3, 2, 1, the answer is 2.
What?
Well, so what's happening here is the binary operators, what they're doing, or what they're allowing us to do, is to perform manipulations on the individual bits of a number. So if you look here, we have our 5 represented in binary. So 1's place is switched on and the 4's place is switched on. 4 plus 1 equals 5. 7, we have the 1's, 2's, and 4's place switched on. 4 plus 2 equals 6. 6 plus 1 equals 7. There's our little binary review. Down here we can perform our operations. So the Bitwise AND, we compare 1 and 1. That's going to give us a 1 because both are true. 0 and 1, not the case. It's going to give us a 0. 1 and 1 again is going to give us a 1, hooray, and 0, 0, wah, wah, is going to give us a 0. So that is 5, and that's how we got 5 for our first answer. Second one, 5 or 7. So only one needs to be true, 1 or 1. Well, both of them are true, so even better. 0, 1, only one needs to be true. Again, it's all good. We're getting a 1. 1 or 1, both is better than 1, so there we go, 1. And 0 and 0, none is 1, so 1 is done. That's just going to give us a 0. And over here, XOR operator, 1 XOR 1. Well, we said they need to be different, right? Well, 1 and 1 are exactly the same. That's going to give us a 0. 0 and 1 are different. That returns a 1. 1 XOR 1, they are the same again. That's going to give us a 0. And a 0 XOR 0, the same, also a 0. So this one gave us a 5, just as we expected. This one returned a 7, right? That's the 1's place, 2's place, 4's place, 4, 2, 6 plus 1 is 7. There's our 7. And over here, the only one that's switched on is the 2's place. So that's very easy. That's going to give us our 2. And if we look back over here, that is what we had predicted earlier. 5 and 7 equals 5. 5 or 7 gives us 7. 5x or 7 is going to give us 2, which is exactly what we ended up with over here. By the way, there's no reason why I was comparing these bits from right to left. It's not like we were doing any addition or there were any values being carried over. It's just my habit. Just for the sake of consistency, I like going from right to left. So I thought I should mention that. We could have just as easily gone from left to right and not had any problems at all. So, all right, next we're going to look at the bitwise complement operator. So here we are, the bitwise complement operator. If you need one of these, look for this little guy on your keyboard from the Latin titulus, currently known as the tilde. The tilde is the bitwise complement operator. So what do you predict will be returned if we apply this to true? You might guess, well, it's true. There's only one other way we can go here. It's the complement operator, so it must return false. So if you guessed false, I'm so sorry, that's incorrect. What's actually going to happen is the compiler is going to throw a stink fit, and it's going to tell us that this can't be applied to Boolean types. So how about integers? What do you think will be returned if we apply this to 4? Maybe, -4? I don't know. What do you guys think? Well, as a matter of fact, the bitwise complement operator on 4 is going to return -5.
What?
So why is that? Why are we getting -5? So, looky here. We have a 32-bit signed integer all the way on the left. We have the signed bit, or most significant bit. This determines whether we have a positive or negative integer. 0 is positive, 1 is negative. And then all the way to the right here, you can see all we have switched on is the 4's place, hence +4. To get the complement of this, we have to flip all of these bits. So every 0 becomes a 1, every 1 becomes a 0, which gives us this big mess of 1s here, which is also a negative number. You can see we have our signed bit switched to 1 now. But negative numbers are stored in 2's complement. So from here, let's first get 1's complement, and then let's make a little more room here. So we get 1's complement, and we'll flip all of these again. So the signed bit is going to stay a 1, and then to get 2's complement, we're just going to add 1 right here. Now why are we going to add a 1? Well, how 2's complement works is it's removing -0 from the equation here. 1's complement is going to give us a binary representation of -0, and if we pluck that out of there and sort of all the other negative numbers shuffle down, -1 is going to take the place that -0 was in, and that's the one that we're adding here. So we add that one, and we end up with this. You can see that the 4's place is turned on, the 1's place is turned on, 4 + 1 = 5. Over here we still have our signed bit switched, so there we go, the answer is -5. Now nothing so drastic happens when we use the previous 3 operators, because the signed bit isn't affected at all. Remember, we were only even considering the first few places here. So just a quick little review of where these operators are applicable. Our AND, our OR, and our XOR, they're okay for Booleans or integers, no problem. The bitwise complement, the tilde, it's okay for integers, but Boolean, it's not going to happen. And then the logical complement operator, I didn't mention this one, but I'm just kind of throwing this in at the end. I wanted to get into the other logical operators in this short originally, but I realized it would be a little long. My last short was a little long, and I'm really trying to keep these shorts short. Nobody likes a long short, right? So the logical complement operator, what do you think is going to happen if we apply this to an integer? Now, if you know the C language, this might look okay to you, but it doesn't fly in Java. This is going to get you a compile time error. Apply to a Boolean, of course, no problem. Originally, I planned on going through all of this in code, maybe in the J shell, and demonstrating all of it again for you and verifying everything I told you. I'm not going to do that, keep it shorter. Before I go, I will say that this material at one time was part of the Java SE Associates level exam, I think. I'm pretty sure it's no longer part of the exam. Doesn't make it any less important, and it certainly doesn't make it any less interesting, worth knowing. If I were you, I would probe a lot deeper than we went today. Whatever you plan on doing for a career, this is good stuff, and it's very basic, very fundamental. So, and a lot of fun, I think. So anyway, guys, thanks a lot for stopping by. There is the music. Not exactly sure what topic I'm going to tackle next time, but I hope to see you there. Don't forget to like and subscribe. And I really, really appreciate you watching. I hope you got something out of this. Take care, guys. Class dismissed.